The intermediate value theorem is frequently tested in the free response section of the AP test. So these problems on this page are from released free response tests. Your textbook does not have problems in this style, so the practice that we do for the intermediate value theorem, we're going to do from released questions. The textbook assignment I give will be more about just regular continuity. So question 1, we know that a car is traveling on a straight track. We have information about that car's velocity, which we're going to call function v. So this is going to be our first time. Everything that we wrote down about the intermediate value theorem, we referred to a function f of x. But that's just a placeholder function. We're going to be able to apply the intermediate value theorem also to v of t, which is what's going to happen here. We've been told we have some information about the acceleration, some information about velocity. We're going to focus here on part C. I left out part A and B because we're not ready for them yet. But we can use the intermediate value theorem here for letter C. For the time interval 0 to 60, do we know for sure that there's a time when the velocity is -5? Justify our answer. So we have been here we go. I knew it had to be in there somewhere. We've been told that velocity and acceleration are both continuous functions. So I'm going to explore the possibility of answering here using the intermediate value theorem. So v of t equals -5. That tells me the velocity, -5, that's an interesting output value. So I'm going to try to prove that somewhere between time 0 and 60, the velocity is -5. So I can look in my table, and if I saw a -5 as a velocity, then I would be done. It wouldn't take any calculus or any even special reasoning. But I see all these velocity values, and none of them are -5. I'm going to try to use the intermediate value theorem to answer. So remember two things that we have to check in order to be able to even think about using the intermediate value theorem. We're going to have to check that the function we care about, in this case velocity, v, is continuous. We're going to have to check that we have an ordered pair, a y value, one that's an output value, one that's greater than, and one that's less than the output value that we care about. So the output value we care about is -5. I'm going to have to look through this table and see if I can find one velocity that's greater than and one velocity that's less than -5. So those jump out at me. You have other options you could use. So I'm going to aim to apply the intermediate value theorem using A as 35, 35 as A, and 50 as B. I'm going to move to a plain whiteboard so I have room to write this out. So especially as we're just getting started, let's make sure that we note when we start using the intermediate value theorem, which function are we going to apply the intermediate value theorem to? So I was asked about the existence of a certain output value of the v function. So I'm just going to write myself a note. I'm going to apply the intermediate value theorem to the v function, which happens to stand for velocity. And I said I'm going to use my leftmost input, my A is 35, and my B is 50. And my K, the output value that I'm interested in, is -5. That's the output value that I was asked to prove the existence of. So once I've got these figured out, I'm going to write myself an intermediate value theorem statement. Remember, I need two things. I need to say that I know, in this case, v of t is continuous, and that I know I have 1 point higher than and 1 point lower than k. And then I'm going to say, since I have those things, the intermediate value theorem guarantees ... So I'm going to type this up. So I've written this up, and I'm going to encourage you to do, I'm going to do what I encourage you to do, which is to make a graph to go with this. Again, you don't have to make the graph, but as we're learning, the interesting output value is -5. This is the t-axis, this is v of t. I'm going to say y, v equals v equals -5. So what I want to do is I want to prove that there is one point on the graph. I picked 35, -10. But that's below, and there's one ordered pair, 50, 0, that's above. And now once I see those two dots and my horizontal line at v equals -5, I'm convinced, like, oh, okay, there's no way to connect those 2 points with a continuous function that doesn't cross through. So wherever it crosses, that's going to be the time value that I've been asked about. I don't have to actually report that time value, I just have to give a reason why I know it exists. So I'm going to say, since v of t is continuous on the interval 35 to 50, and v of 35 is -10, which is less than -5, and v of 50 is 0, which is greater than -5, the IVT guarantees that there is some value t in between 35 and 50 at which v of t equals -5. All right, take a look at number 2. Remember, I'm taking these from release-free response questions, so there's multiple parts on those problems. And we've just started, so we only know how to do one of the many parts. So that's why I've just highlighted letter D here. So let f be a twice differentiable function. You don't know what that means yet, but that's okay. It implies continuous. That's what you need to know. And I know 2 ordered pairs on f. That's good. It's good. I always like to start an intermediate value theorem problem by knowing some ordered pairs. And I have this information about g being a function that's given with that rule. It turns out letter D doesn't require that part at all, so I'm just going to cross it out so it doesn't throw us off. I have a new function h, which is based on f. And so this explains why there must be a value r such that h of r equals 0. So what am I going to need in order to prove the existence of this output value on the h function? Well, if I'm going to use the intermediate value theorem, I need to know that h, because now even though this starts off looking like it's a question about f, this is a question about the function h. So I need to know that h is continuous. I'm giving you a shortcut hint, which is differentiable, means if a function is differentiable, it must be continuous. And then I'm going to need one point that is greater, like higher up than, and one point that is lower down than the horizontal line, h equals 0. So they don't usually mess with you too much. Here, they haven't given us a table. The places you're definitely going to want to start investigating, and you're almost certainly going to find the 2 points you need, are the 2 points that you have any information about. So I'm going to figure out h of 2 and h of 5, because this sort of implies that I might have good luck if I let a equal 2 and b equal 5. And notice here's my k equals 0. And what function am I going to apply the intermediate value theorem to? The function that they've asked about is h. So I'm going to go to a different whiteboard. I'm going to figure out some output values on the h function, and I'm going to write up the intermediate value theorem statement. All right, so I wrote down some things that I know. I know a formula for finding values on the h function. I know 2 points on the f function. I don't know these for sure, but I'm going to sort of start with the assumption that I'll probably have good luck if I use a equal to 2 and b equal to 5, just because they're the 2 input values implied in the problem. And the interesting output value that I care about that says k equals 0 is 0, and I'm applying the intermediate value theorem to the h function. So, number 1, do I know that h is continuous? Yes, but only because I told you that differentiable means it has to be. We'll talk more about that later. The second thing I'm going to need is 1 point above and 1 point below, but I need points on the h function. Right now all I have is points on the f function. So I'm going to experiment with the h function. I won't have to experiment too hard. They're not going to mess with you here. If I tried to figure out h of 2, I'm going to use that function rule. That's going to be f of 2 minus 2. That's me using the h rule and replacing x with 2. What is f of 2? 5. So h of 2 is 3. So I have one ordered pair, 2, 3. Now I'm going to find h of 5. Remember, I'm using this H rule. That's going to be f of 5, take away 5. Well, f of 5 I've been told is 2. 2 take away 5 is negative 3. So I have a second ordered pair, which is 5 comma negative 3. All right, so over here on the right-hand side, I'm going to collect together what I know. I am going to use, well, so did I find one ordered pair above and one ordered pair below the horizontal line, h equals 0? I did, because my two output values are positive 3 and negative 3. So I'm going to put my two ordered pairs here, 2 comma 3 and 5 comma negative 3. Let me try that one more time so that really looks like a 5. And then I'm going to erase all the rest of the stuff so I can write an intermediate value theorem statement. All right, so here's what I've written so far. In order to use the intermediate value theorem on h of x, I'm going to have to show that I know h of x is continuous and show that I have an ordered pair above and one below the interesting output value, which is 0. So we have to use that information from the top of page 3 of your 2.3 notes. I told you, because of calculus we're going to do later, that f of x is continuous. But we have to say why we know h of x is continuous. So remember that if you add or subtract or multiply or divide two continuous functions, or you compose them, so make one continuous function the input to another, then the result is also continuous. So I've set up here, since f of x is continuous because of calculus, h of x is also continuous since it is formed by finding the difference of two continuous functions. So f of x is continuous, and I subtract the function x, which is just linear, which is continuous. So I've combined two continuous functions, so h of x must be continuous. Once I've said that, now I can use the intermediate value theorem. Since h of x is continuous and I have these two ordered pairs I need, h of 2 is 3, which is bigger than 0, and h of 5 is negative 3, which is less than 0, I'm going to make my conclusion. So the intermediate value theorem guarantees that there is at least one. Try to use the same words, in this case the same variables for the problem. They asked us to say why there must be an r, so I'm going to use r. There's at least one r, which has to be between 2 and 5. For which, what was I trying to prove? That somewhere on h, the output is 0. So for which h of r equals 0. That's your write-up for the intermediate value theorem. I would not necessarily have made that S in so capital, but I promise that they're not going to mark you down for that on the AP test. They do very much, they go through all kinds of hoops to make sure that they grade you on your calculus and not on, grammar, things like that. So start the next problem. Do what you can. Try to find the pieces, try to find the little statements that you're going to have to piece together, and we'll review the answer to number 3 in class tomorrow. And don't worry about a textbook assignment. Enjoy.